Okay. Sorry, give me a minute. All right then. Like I said earlier, my name is Salim Moilullah, and welcome. I'd like to welcome everyone of us to this event. This is the Students Ambassador events, and over the next 90 minutes to hours, myself and Shola Kumi would be educating attendees about in Microsoft's products or that interests us basically. So we'll be talking about how to create a regression model with the Azure Machine Learning Designer, and it will be presented by Salim Oinola and Shola Kumi, like I said earlier on. So yes, Salim apparently. And Salim is the Microsoft LensSense ambassador. I am Salim, by the way. And Salim is a beta Microsoft LensSense ambassador. I also build AI solutions with Python and I write technical articles. And here we have Shola Kumi. Shola Kumi, introduce yourself.
Okay, hello everyone. My name is Shalakumi Idile, and I'm an Alpha Student Ambassador with Microsoft Learn, and I am into offensive security, penetration, and vulnerability testing. So cybersecurity. Two different worlds. You have machine learning with Salim and cyber with Shola.
All right, so thank you very much, Shola Kumi. All right, so the prerequisites for this event is pretty basic. We also have an Azure account for students, an Azure for student account. So basically, if you don't know what Azure is on Microsoft's cloud computing platform. And what cloud computing does basically is that it gives you the ability to have a quote unquote compute resource on the cloud. Yeah, that's what it does basically. And then another prerequisite is the ability to navigate the Azure portal, which I assure you it's really user friendly, because I mean, if the users if the producers of Windows were to create a cloud platform, it's only logical that to be user friendly. So I assure you that it's user friendly. Okay, so and the learning objectives is just to learn how to train and publish a regression model with Azure Machine Learning Designer. Right. So the agenda rather. So you have introduction to machine learning. I'll do that. We have introduction to Azure ML and ML Designer. We have create an Azure machine learning workspace and compute resources. You'd explore the data. You create, run, and evaluate a training pipeline, and then you'd set up an inference pipeline and REST service endpoints. All right, let's begin. So yeah, machine learning. Machine learning is like machine learning, Kubernetes, Web3, cryptocurrency. These are like those buzzwords that are like out there in terms of tech in 2020, in the last 2-3 years actually. And like machine learning is thrown around so often. Like, what is machine learning? I mean, so machine learning is a technique that uses mathematics and statistics to create a model that can predict unknown values. Okay, I mean that makes sense. But like, if I were to explain machine learning to you, the most basically machine learning is training a computer or a model rather to think the way a human being thinks. So like as a baby, the way you learn is you learn by trial and error. So let's say you have I don't know, a lantern, a hot one, yeah, and a baby goes there and it touches it and it gets hot. Now that little thing right there, baby now knows that next time he sees something shaped like a lantern, be rest assured that the baby will be hesitant to touch it because now he has learned from that little example. So in that little analogy there, the first scenario is the data sets, and then the second scenario is the test. So basically, the whole concept of machine learning is you feed your computer or your model with data where it knows the answers, and then after a couple of it's after like feeding it with so much data, you then ask it to predicts for a new value. It's almost similar to how we do maths back then in secondary school, whereby they introduce a new topic to you, they give you a couple of examples, and and then using the insights or like the knowledge you gain from the example, you're then able to now work on new examples. So you can't talk about machine learning without making reference to data. And machine learning is often associated with ML. ML is like the quote unquote acronym. AI and ML. AI is artificial intelligence. And machine learning is a subset of artificial intelligence. Okay. And then you have deep learning. Deep learning is a subset of machine learning. So like that's the flow. Deep learning is a subset of machine learning. Okay. And then machine learning is a subset of artificial intelligence. And then we have data science. Data science, I won't call it a subset of any of those, but data science exists such that machine learning depends on data science. Because like I said earlier, it depends, like you need data, you need to be able to feed your data. The strength of your machine learning, it's most often than not, is usually a function of your data set, okay? So you need to be able to like work with the data, you need to be able to play around with the data basically and see from the data, being able to get insights from the data. So that's why data science is quite important in terms of machine learning. So here we have machine learning, and we have two various forms of machine learning basically. You have the supervised and then you have the unsupervised. So basically the supervised machine learning is further divided into regression and classification. So let me start with this division first, the supervised and unsupervised. Supervised machine learning is the machine learning such that the data set tells you it's labeled. I mean label is like the data set exists such that it has features, and then the features has like an answer. So it's like, oh, let me use the mathematics example with your high school. When you're given those examples and then they solve the example, you understand? Like it's labeled. So like the data sets, what you're using as your example, what you're teaching the quote unquote computer, it's labeled. You can see the answer there. And then after giving those that data sets, we then ask it to do something. Now, what you're asking it to do is the basis for the second division. With regression, you're asking your computer to predict a range of values. They can be, it's basically a value. It could be a random number. It could be 1000 and 1000.34. Okay. However, classification, it's mostly binary, but it's not limited to binary classification in the sense that you can just be like, having given these features, then I need you to classify it into big or small, good or bad. It's basically binary, 0 or 1, mostly binary. However, you have instances where you can have multi-class classification algorithms. However, unsupervised machine learning exists such that there are no labels. So imagine your teacher came to class and back then is like it gives an example and then it doesn't solve it. Like there's no answer to it. But then you need to be able to train a model that when it sees other ones, it can like give you good insight on it. So obviously you can't train the model to give you the answer. What you do with that is like you have a clustering system. This clustering system works best in the example I can give off the top of my head is when you have your emails, when you have spam emails and not spam emails. That's it. That's like the most real life clustering algorithm out there. Okay. And let me give other real life examples of regression and classification. So if I had a model that's able to predict the price of my car, okay, now that is a real world example. That's a regression example because I mean the car is not going to be. I'm not asking you to. I'm not asking you to tell me the car is expensive or not expensive. Yeah, I was asking for expensive or not expensive. Now that is a classification model, and I'll have to set a threshold for it. Okay, this is where you stop at expensive. This is where you stop at not expensive. Okay. So let's just let me ask a little question here. If you were to predict the prices of a car, what features do you think are important? Like, what do you think should be in your data sets? Do you think? Okay, I'll give an example. I think if you have to predict the price of a car, the make of a car is extremely important. All due respect to Toyota owners here, but I mean the price of an average Toyota car is different from the price of I don't know a Rolls Royce. So let's give other examples. Let me get back to the meeting. I'm missing a chat bottle. Let's give other. What do you think about like features that can be used to train a model that's able to predict car prices? So I said karmic. Which other one? I don't want to say anything on the chat, but I mean it's quite easy, isn't it? Anyone?
The year was produced.
Oh yeah, that makes sense. Definitely. Obviously, the Corolla of 27, 2007 will be less expensive than the one for 2009. That's right. Any other one? Horsepower. That's very rational for me. So basically, like those are the kind of features that you need. And obviously, it's very important to have the right features for whatever you're doing. So that's just basically the tree of machine learning, basically the classification tree of machine learning and how it works. So now let's now talk about machine learning in tandem with Microsoft Azure. So we have these are 5 tools here. And what you should note about these 5 tools is that when you're working with these 5 tools, the level of proficiency you should have or the level of assistance you need on the computer increases, no, it decreases from left to right, basically. So what this means is that when you're deploying, you need like you do a lot by yourself. And when you're working with AutoML, where the computer will do so much for yourself. So AutoML stands for automated machine learning. So the entire process I just talked about now, it's done. All you need to do with AutoML is just feed your computer the data and it gives you a model. That sounds pretty easy, right? Then we have designer, whereby you have to basically what you do with designer is you have like a pipeline and then you start from the data, you work on the data, and then you have your model. However, you are doing all that on a GUI. A GUI as in a graphic user interface. So it's pretty easy, like it's intuitive. Okay. And someone who's writing a line of code can do that. Right. And then with Jupyter Notebooks, you have to write code. You're thinking about importing sklearn, importing pandas, importing, all these data science and machine learning models and modules rather. You import them and then you work with them. You do your hyperparameter tuning, just play around with the data, trying to get the best algorithm out there. And then experimentation, this has to do with like data science in the sense that you experiment with your data sets. And lastly, deployments. Obviously, when you're deploying, the PC will not deploy for you. You have to do that by yourself. And underneath here, we have compute and data sets. Okay. So, like I said earlier, data sets, your data is like very important in your machine learning model. It's almost, I would say, it's like the food of a machine learning model. It is actually, it's like the food of a machine learning model. Your machine learning model won't work unless you have not just data available, but you have good data available. And then compute is important when you talk about cloud computing, basically, because that's what cloud computing is all about. Cloud computing platforms like Microsoft Azure and other ones, yeah, what they are selling is the compute. That's like they're selling the compute resources. So that's what they are able to like give you out there. I don't know if I mentioned earlier with the Azure students accounts, must have skipped my mind. So basically, as a student, in line with Microsoft's dedication and commitment to helping students, if you create a Microsoft student account, you get, I reckon it's $200. I think it's $200. So you get $200 free on the account. Am I right, Shabakumi?
Yes, you're absolutely correct. All students, Azure for Student account, you get $200 for free.
So you get $200 for free, and basically you can do a handful of things with $200 in terms of cloud computing. Can deploy your static web app. You can have your Azure functions, like a plethora of things you can do with that. So I think you should consider checking that out. And now let's talk about the compute targets. All right. So basically, there are 4 of them, and I will explain each of them and what they do. So I have something called the compute instance. Now, this is like, it's explained here as the development workstations that data scientists use to work with data and models. The most important word in everything I just said now is workstation. So your compute instance is like, if you work with Python, I'll call it your virtual environment because it's like where everything you're working on, the model you're creating, where everything is, it's a workstation basically. Like nothing quite encapsulates the whole essence as much as the word workstation. It's where everything you've been working with, it's where it's done. And you see it with the live demo which will now come very soon, okay? And then we have something called the compute clusters. This is the scalable clusters of virtual machines for on-demand processing of experiment code. So let me explain what virtual machine is, first of all. In cloud computing, a virtual machine is basically a virtual computer system, or basically a virtual OS. So imagine perhaps I'm working on a PC right now, yeah, and with a cloud computing platform, can create a version of this PC or like a PC that would be hosted on the cloud. Obviously, there's no physical. You have a physical form. However, you have like it's on the cloud, whereby you can use it to compute things you want your regular PC to compute. So you can install things on it. You can, as a matter of fact, you can run like a Jupyter notebook on a virtual machine. I don't know if you get me. Like you can always like you create your own PC on the cloud, and then you can configure it to whatever you want. You can have it like in different RAM sizes, different ROM sizes. Like imagine like having an entire PC to yourself on the cloud, and obviously it comes with the price. And we also have something called the inference clusters. Oh, I'm sorry. So I talked about virtual machines there. So a compute cluster is now scalable clusters of those virtual machines. So basically that's what will run your code. So you have the workstation, then you have what will run your code. This is like a scalable clusters of those virtual machines. Then we have something called inference clusters. This is your deployment targets for predictive services that you use your train models. So basically, inference clusters is its work is usually revolves around the cadence of deployments, right? And lastly, we have something called the attached computes, which links to existing Azure compute resources such as virtual machines or Azure data lake clusters. So what this is doing is it's like the link between your compute resource, between existing compute resources. So I've talked about a virtual machine is now an Azure data bricks cluster is a cluster of Azure data bricks. Now Azure data bricks is an Azure service, and what it does basically is it does data analytics. Like I said earlier, you can't talk about machine learning without going back to data science, data analytics, because you have to know what your data is like. You have to perform. There's this concept called EDA, explanatory data analysis. So you have to perform data, know what the data is like. And I know what I'm saying now might seem a bit out of place, but with after Shulakumi's live session, it will make much more sense. Trust me, it would. So now let's talk about the Azure machine learning designer. So I've talked about machine learning, and most times when you want to work with machine learning, you do it on a Jupyter notebook. Basically, you write a Python file, an interactive Python notebook. You write something like that, and then you have your workflow, you work with it, and it's all nice. You write loads of code. Like I said earlier, you import different third-party modules on Python. However, with Azure Machine Learning Designer, you can do all that, which, as I said here, you can train, test, and deploy your machine learning models with a nice drag and drop interface with clearly defined inputs and outputs that can be shared, reused, and controlled. Now, this is very interesting because even with the Jupyter notebook I was talking about earlier, it's limited to just training, testing, sharing, and reusing, and a little bit of control, But the control is limited compared to what you have with Machine Learning Designer, with the Azure Machine Learning Designer, because Jupyter notebook does not cover deployment as such. You have to do that on your own with Spider and other deployment platforms like Microsoft Azure's web apps. So basically, with the Azure Machine Learning Designer, you have all of that encapsulated in one. Now, obviously, it has features. They have 4 features: pipelines, components, data sets, and jobs. Now, to explain these features, let me show you this image. So you will see this, don't worry. You see this when Shulakumi starts live session. So this is a peek of what the Azure portal is all about. And like I said, it's pretty intuitive. So let's start with pipelines. You see the pipeline here where I have my mouse talking around. The pipeline is basically, I think the pipeline word, it doesn't describe it as such. What describes it more is the word flowcharts, right? So you have like a series of steps. So basically, when you have the process of moving from the data set to a finished model, that process, you have it all out here. That's the pipeline. Basically, moving from your raw data sets to cleaning the data, to splitting the data into test and validation sets, to all do it again. test and validation sets, basically to perform, you can scale the data depending on the type of data. Basically, the things you can do depend on how good your data set is, like, and how much you want to work around with it. You can clean the data. So basically, a lot of the things you do is on cleaning the data. So all of that, moving from the raw data set in .csv in CSV format or whatever format it is, moving from that all the way to your train model is what you're going to have in your pipeline. And you're going to have all of that in here, right? And then you have components. Now, components is basically I call it a box in your flowcharts. This right here is a component. You add columns. So basically, perhaps after you have your data sets, you want to add columns to it. You do that here. That's a component. You basically just drag and drop. I can't do that because this is just a picture. But basically, what you do is you drag and drop. You can add rows. You can apply image transformation. That's a component. And then you have data sets. Now, data sets is just the data you're going to be using. You can have it in different form. You can import it. You can use the Microsoft provided data sets. You can have it from your local device. You can have it from the web. You can just get your data anyhow, okay? And then you work with it. And then jobs. Jobs is basically running the model. That's it. Like, just going to run the model. Like when you have a machine learning, an Azure machine learning designer job is basically when you submit and then it works and then you see it run. It takes a while. That's a job. Okay. So regression. When I talk about regression, I'm sorry I'm rushing a bit now. I realize I've used a lot of time. They have numbers. It gives a numeric outcome based on variables. Like I said earlier, regression is when you're predicting a car's price and then you want a price. Obviously, I'm going to have a number. 50,000 naira. That's your car price. That's a bit unrealistic, but you get the idea. And then when you have supervised machine learning approaches, you have both features and known values. Like I said, the labels are predicted for items with unknown labels, right? So you have it's labeled, you have the answer, you know where you're going towards. And then after you're giving this example, you now say, okay, now do this one. So like the car price, I think this is more realistic than the 50,000 example I gave earlier. This is $10,000. So training and evaluating a regression model. Basically, I talked about the pipeline earlier on. So this is like a schematic explanation of what the pipeline is like. First off, you prepare your data sets. You identify the features and labels in the data sets. You pre-process it or you clean it, like I said earlier. You transform the data as needed. So it's based on your needs. If the data is really nice, you don't need to work much on it. If the data is a bit tedious, then you need to train up a couple of not basically if the data is not nice, but if the data is not nice in tandem to what you want to do. Okay, so the data might be okay for some other thing, but then what you want to do, it's not exactly that. So you have to clean it to that effect. And then you train your model, which is, I talked about this earlier, you split the data into two groups. So obviously, if I'm giving an example, if I'm giving a classwork, basically, just split it into two. So to predict some and to leave some as like validation tests. Like you already know the answers to those ones. You now tell it, okay, predict for these ones. Then you check the answer you predicted, your model predicted, and the answers that's given. Then you compare them. So you need to be able to test your model. You can't just put your model to production like that without being tested. And then you evaluate your performance. You evaluate your performance. You compare how close the model's predictions are to the known values. Because obviously now that okay, perhaps after testing it, you see okay, the model does well on these data sets, but then on this splits, for instance, and okay, in perhaps in examples where I don't know, you can't make is this one, it doesn't do so well. Then you can evaluate it and then a lot of back and forth in there, and then you have a very good model at the end of the day. And lastly, obviously, I'm not going to use the model by yourself. You have to predict the model. So you predict you deploy a predictive service and on the server and all that. So with that, I would pass the quote unquote button to Shola Komi. She would take us through the demo session. Shola Komi, are you there?
Okay. Yes. Thank you very much, Salim, for that very intriguing introduction. So let's get to work to breaking all the big terminologies that he has said. And I want you to be able to see it in action. So let me start sharing my screen. Second. All right. So to begin, like was mentioned earlier, you're going to use an Azure student account, which is something similar that I'm going to be using. So we'll begin by going to portal.azure.com. Just a little stuff. If you're interested in following along with what I'm doing, you can also decide to do so. Perhaps I should send the link to what I'm following. It's on Microsoft Learn. It's a module on Microsoft Learn, Explore Regression with Azure Machine Learning Designer. I could send it to the chat, or Salim, do you have that handy?
I'll do that.
Okay, so you can please send that module, that exercise module to everyone so they can also see what I'm doing.
I think it will, but I'll
So,
send that.
all right. So while that is going on, so the first thing we're going to do is to create a resource. He has explained what resources are. So let's start by creating a machine learning, Azure machine learning resource. So we're going to search for that. Azure machine learning. So this is how you know this is what you're looking for. I put it in my favorite so that it also be there. Like I could also get it at hand anytime. So first you create a machine learning resource so you can be taken to the Azure Machine Learning Studio, and then you start your designer from there. So you would select your subscription. What should show for you if you have an Azure for Students account is Azure for Students subscription. Mine is Visual Studio Enterprise. And then you have a resource group. If you don't already have one, you would create a new one. So we can call this regression analysis. Regression analysis. It doesn't accept spaces, so you have to use using an underscore. You could use any other symbol you like. So regression analysis. Okay. Now our workspace name could be event demo. Then your region is the region that's closest to you. So I'm choosing South Africa, not since we're in Africa, and I think this is the closest. Before this was here, I used to use Western Europe because for some reason there wasn't Africa on their regions. So yes, I've done that. So these four things now are going to change. Actually, the last one is going to change. We don't have any container registry right now, so it's going to be created automatically. But the storage account, your Key Vault, and your application insights, just do well to remember these three. Key Vault is for the security. Storage is where your workspace is going to be kept. And application insights is just all things you're doing, just putting it there. So when we're done with that, we'll click on create. Just realize that change is to light mode. Let me see how I can do that. Please give me a second. I should be able to change the light mode. You know what? Just let's continue. There's a certain position I'll be able to change the light mode. I can't understand why it's not showing the settings, but we'll go to review and create next. We're waiting for this to create our workspace. And when that is created, we'll move on to the next step. Okay, so we just finished validation, and so it's going to create now. This notification place here at the top would show us when it gives us insight in everything we're doing. So missing jobs, all of that we're doing later on. So when we want to be sure that it's done, we'll see the notification at the top here. So right now, this workspace is still deploying, so we need to wait a bit for that. But yeah, that's how it is. Fortunately, we wait. So that's how everything here is. We wait, we wait. Sometimes it can be very fast, sometimes it can be painfully slow, but it's all good. So yeah, it's still deploying. It should be done very, very soon. My deployment takes a lot of time. But what we're going to do next is we're going to actually go to the portal for machine learning. Okay, it's good. Oh, great. So it's done. Event demo. So we have our key vaults, application insights, subscription we're using, links to the storage, then web URL. So let's now go to Machine Learning Studio. So we click on ml.azure.com. Here for me. So you have to sign in with your account. Make sure to use the account that has your Azure subscription. All right, so this is how it looks like for me. Welcome to Azure Machine Learning Studio. Thank you very much, Azure. So we'll go to workspaces, and the workspace you just created should come up here. So event demo. So it takes us to that studio for our workspace event demo. So like he was explaining, this is how it should look like. Okay, now I should be able to change to like mode. Perfect. Yes. Sorry, I'm very much accustomed to dark mode, so let's make this accessible for everybody. So this is what he was trying to explain. This is how Studio looks like. So you have under author, we have notebooks, automated email, and designer. These are some features of the Azure Machine Learning Studio. Then we have data, jobs, components, and all of this you'll see very soon. Then of course, compute, data storage, link services, and data labeling. So let's start with compute. Remember, he mentioned the 4 different kinds of compute. You have compute instances, compute clusters, inference clusters, and attached computes. So we're going to compute clusters. And we want to create a compute cluster dealing with virtual machines here. So of course, we need to do that. So remember, the location is the same as the region in which you originally had when you were creating the workspace. So it's South Africa North. Then our virtual machines here is going to be dedicated, not low priority, because we don't want any low priority. I mean, we're working with training a model, we don't want it low priority. Then, of course, the CPU for virtual machine type. Then for virtual machine size, we need something that works much better, more RAM and storage. So we are not selecting from this, which is already selected for us. We are going to select from all options. And what I'm going to use is standard DS11 version 2. I'm using this because it's much more feasible for me, and looking at the amount of credit I have, I don't think I would like to waste that. But if you have a larger subscription, you can go for something much bigger. It's much faster for you and then very efficient, but I don't have money, so this is what I'm going for. It's a standard DS11 version 2. So when you click that, then go to next. Now, what should be our compute name? Well, let's say events. No, we've already chosen event testing. It needs to be different name. Perhaps MLSE regression events. Anyone has any random name they want to give me, you can unmute and speak. I'm waiting.
Word name, yeah?
You said?
I said word name, yeah?
Yes, any random thing. Just something I can easily remember. Come on, no presenters, no presenter, no Salim, you're not meant to give us a name. Someone else from the audience, just unmute and just give us a random name. Going 5, 4, 3. Adiola.
Loves Shola.
Are you serious? All right, I'm actually going to do that. All right. Adiola loves Shola. Okay. Minimum number of nodes is 0, then our maximum number is going to be 2. Then idle seconds for before scale down, it's going to be left as it is, 120 seconds. And then we're not enabling SSH access, so we're just going to leave this one selected and then click on create. So we're going to wait for this to create. This shouldn't take a lot of time. So, all right, it's done now. So now let's go back to our menu here, expandable menu, and we are going to go to author. Now this is the view deal designer. So we're going to start with that interactive drag and drop thingy that Salim was explaining before. It's very fun, really. It's super fun. And I hope you feel that way by the time we're done. Let me reduce this since it seems too large. I don't have a large screen. So okay, I think that's the most we can go. All right. So let's configure this pipeline first of all. Yeah, so it's a compute cluster, which is what we created earlier on. And the compute cluster that we created should be here. Then the draft details. What we are doing is to predict the price of an automobile, like the illustration that Salim was giving earlier on. So we're going to have to change this to auto price training. Automobile price training. Okay, so I guess this is over. So yeah, so this is done. All right. So we've created that. We've done all that. Just we always make sure that it's compute cluster that is mentioned there, and then you put in the name of your compute. So let us now start with everything we want to do. So Azure Machine Portal design already has data set that we're working on. It's already placed there. And so we are looking at auto mobile. So, right, data. It's going to be in data. That's something I should have explained. So on this asset library, this is called an asset library, we have data and components. So this is what will contain any random data. This, first of all, is what we're going to get this data we're going to work on. And then components are the things that now help you with training and testing. So you have add columns, and plenty of other things. We're going to work a lot of times with this component part, but let's just bring in our data. So mobile price data. And so you drag and drop here, very satisfying. So now we want to preview our data. We want to know what the data looks like. So we go to right click and we go to preview data. So come here so we can really check out this data thing. Okay, so this is what we're looking at. It's a CSV file that's already been integrated into the pipeline. So we have different rows and columns with different things that features that can help you to predict the price. So of course, price has to be at the very end. So it's here. These are different prices based on different cars that have all of this different functionality. Now you notice that normalized losses has some NEN, like null empty values. So we need to get rid of that. We're going to do that pretty soon. And then some of these values here are not regular. So we're also going to have to do something about that. So this is what it looks like, basically. Now, let's close this and be sure we're seeing our data here. Now, let's go to add our data transformations. So we're coming over to components. It has the wide range of values that we use for transformation and monitoring. First of all, we're select columns in data sets. It should already come up. Yes. True and trustworthy. One begins, you connect the outputs from automobile price data, connect with data sets. This is fun. So we've connected the outputs now. So we want to edit this. Remember that some of them had null values. We don't really need that. So we're going to double click on that. We're not right clicking this time around, we're double clicking. So we're going to edit the data we have by name. The one we're getting rid of is normalized losses, because every other thing has numbers apart from normalized losses. So we can add all and then just remove normalized losses. Or if you like stress, you can decide to add all of them one by one and then remove normalized losses. We don't have the time for that and we do not like stress. So we are saving all of the settings that are here are going to be left. They don't really affect in any way. You can explore them at your own leisure time, but what we're really working on is run settings. So, I mean, looking at selecting columns and removing that which had something we did not need. So we're done with this. So it's connected. Now, next thing we want to do is to clean our missing data. So we're going to come back here and look for clean missing data. Done this quite a number of times, so these things will also. So we're also going to put that here. I'm going to connect to this. We're cleaning our missing data. Now you see that it has some kind of alert here that something is going wrong. So I'm going to also double click on that. So we check what the problem is. So I'll come here and we're going to use with rules this time around to clean our missing data. So some of the columns that have issues are, there are three: bar, stroke, and horsepower. So let's look at bar, make sure that it's the exact typing. Stroke, this should pop up already. And horsepower. Horsepower. All right, so these three, remember, it's column names, bar, stroke, horsepower. So we save with rules. Now, next is for the minimum missing value ratio. It's going to be left as it is. Then maximum missing value ratio will also be left as it is. Then cleaning mode is to remove the entire group. We're removing those rules. Reason being that perhaps the data also has something missing, or it's not going to affect, or it's going to poorly affect the prediction of this regression model that we're currently training. And so we don't need them. So we're just going to remove them for stroke horsepower. See you later. So yeah, that's it. So we're done with clean missing data. Be sure that everything looks all right as it is. Then next, we are going to normalize data. Pay attention to what I'm doing here. There are going to be questions at the end. So let's see who can answer our questions. Clean, normalized data, we've gotten that out. If you look at it, it actually gives a small explanation of what all of these things are. We have normalized data. It rescales numeric data to constrain data set values to a standard range, meaning that it just helps us to get everything proper. So if you want something to be on the same scale or standard range, something like that, yeah, that's what normalized data is there for. So we're in here. Now you see that clean data has two outputs. So which one of them are we connecting to normalized data? We're connecting this. This is cleaned data set. So this has already been cleaned. The fact that we put clean missing data here, this first one, automobile price data, has been cleaned. So we're going to normalize. We don't need cleaning translation. We need clean data sets. So we're connecting to that. Something is also wrong with normalized data. So we also have to work on that. Now, our transformation method is not going to be z-score, but it's going to be minimum and maximum. Remember that we had a minimum cleaning rate or maximum, we had 0.0 and 1.0. So this is what we're going to use. And we're going to have to edit our columns. We're leaving this use 0 for constant columns when checked true, editing our columns. Now, I wrote down all the things that we're going to edit. We're using I think it's with rows. Hold on. Yes, column names. So it's with rows. So let me get them out from my here. All right. So they're about 14 or 13. So we have, first of all, we have symboling. Then we have wheel. We have, and all of these are going to be normalized. Wondering why that's not coming up. We have length as well. Perhaps I should just. It should pop up, but typing them in. Let's just try again. Symboling. Okay, perhaps it just wants me to type in. Excuse me. Symboling. Next we have wheelbase, which is here. Then next we have length. Yeah, we also have width. We have length. Then we have height. Then we have per width. Truthfully, I don't know what majority of these things mean going to be used in training this. I mean, there are features of cards. I only know a few of them, but the rest look very, very foreign. Engine size. Let's see. Okay, that one makes sense. Bore, I've never heard of something like that before. Or then stroke. And compression ratio. And horsepower. Influence with peak RPM. 60 mpg. And the highway mpg. So these are the columns that need normalization. Let me be sure they're all here. Symboling will be showing height, purpose, size, forest stroke, compression ratio, horsepower, peak RPM. All right. So we have all of that there. Now, the reason why we are putting some of these things here, stroke, peak RPM, and TTMPG. Now, the scale in which they are measured are quite different. So, on the fact that the values in peak RPM will now like affect our prediction, like I've said. So we need to normalize data so that they are put on the same scale. So that's all. We don't need to do anything with output settings, run settings, no info component information. No. So this is it. So with these 4 things we've done now, we're going to do the first running of the pipeline. First, let's make sure everything is according to normal. So we connected with mobile price data output to data set, then results data set from select column in data set to clean missing data. Then the leftmost of clean missing data, the output there, you connect it to normalized data. So yes, let's submit. This is all good. We're going to create a new pipeline job. And we're going to call it MS Learn Auto Training. No. MS Learn Auto Training. Job display name is auto price training, like I wrote earlier on. And so it's created on this blah blah blah. So we're waiting for it to run. So like I said, notifications up here, and also here is when we'll see when it's done. So we'll see completed there with a check mark in green. We see that to be done. This is one of the situations where these jobs run very slow, so we just wait. Like I said, this is the first step in our pipeline here. So we have to make sure that we're submitting this, making sure that all of this works as it is. Because if all of this don't work, we don't clean the missing data, we don't normalize, then our future steps and eventually testing will be affected. So we need to make sure that this is working as it is. Wait. Please be fast, please be fast, please be fast. In the meantime, does anyone have any questions what I've done so far? Anything not clear? I can just briefly explain during this waiting period. Is anyone trying it by themselves? Is anyone also doing something similar? And have you encountered any issues? I hope you can hear me. Salim, sorry, can you hear me? Hello? Am I being heard?
Yeah.
Yes, yes.
Okay. Thank you for the feedback. All we're doing now for those that just recently joined is that we've already gotten our data pipeline on Azure Machine Learning Designer. And so we submitted the first set of jobs in which we've selected some certain columns in data set that we want to remove. And we've cleaned some of the missing data, and then we also normalized data, putting everything on the same scale. Some of them that have null values, we've removed those things and things. So I'm waiting for this first set of jobs to run. This is surprisingly taking a lot of time. But what we're going to see next is we're going to click on this job detail. It's going to take us to an entirely new page. What we should actually see here is the everything completed. It's still running, so it's going to take some time to load. But everything should be completed. You would see this here, you will see some green ticks showing you that the run has completed. So it's still going ahead, that's why it's loading here for us. I just hope it doesn't take much time for other jobs that are going to be running because it might be much hectic. But let us see. Let's look for first.
All right, so just a little thing to note how the job is running basically. So as you can see with the pipelines here, like it's pretty like fair with further comments up, it's pretty intuitive and we can follow through with it. But basically, what the Microsoft Azure Machine Learning Studio does is that it abstracts the entire writing code out of it. Like for instance, if you were to select a column in data sets, you know how here we just have like a drag and drop thingy here, and then you have it on the workspace. In Python, you're going to have to like write basically you're going to write code. And that's like the biggest or like how like put like the biggest thing the Microsoft Azure Machine Learning Studio does. Like it just abstracts that whole process out of it, but you don't have to think about. And I mean, it even goes as far as not having to think about installing a text editor, a Python interpreter, or like in machine learning in the old machine learning domain, they have this thing called Anaconda. So Anaconda, it comes with a text editor, a code. It's not really a text editor as such, but basically it does the work of a text editor and an interpreter, all of that. And like you have to install, configure it for your system, and like it's a lot of things that go on there. But like all that, you have to do none of that with what you have here with the Microsoft Azure Machine Learning Studio.
Yeah, thank you very much for that input. So it's already getting, yeah, it's completed. Woohoo, thank God. So, like I said, everything should have some green ticks, meaning that the first submission on the job has completed. So it has done all of this. So we're good to go for the first part. So let's move on now. We're done with normalizing that. So let's continue now. We want to go back to our asset library and look for split data. Yes, split data under normalized data. So we're going to connect transformed data set, which is the one on the left. There's transformation function, and then there's transformed data set. We're connecting the one on the left to this for splitting data. Splitting data partitions the rows of the data set into two distinct sets. You would understand what split data does pretty soon. So we're going to also have to edit this. So our splitting mode is to split the rows into two. The fraction of the rows is going to be 0.7, then the randomized split, which indicates whether the row should be randomly selected. We're going to click on true. Then random seed is providing a value to see the random number, meaning the random rows that will be collected. So how random it should be using 1, 2, 3. Then stratified split, or leaving that as it is. So it's indicating whether these rows that are splitted, like should they be grouped into different like columns, how we're going to do it. So we're not interested in that, putting false there. We're leaving the rest as we've done, and then we're closing this. So this is good. Now let's look for train model. Remember, we're still working on components because components is one that helps us with transformation. So nothing on data yet. Train model. All right. Thank you for opening up on time. I'm placing it under here too. This is how it looks like so far. So we're in train model now. Since we're predicting the price value, we are going to connect this first one here, the one on the left, to the one on the right. The one on the right is data set, data frame directory, and this is the results from the first data set. So this is all we need. We don't need this one here. It doesn't need to be connected yet. So let's also edit this. Remember, we're editing the column again. Training price. So it needs to be trained. We need to put in our price. make sure that it's the exact word and spelling. So save, and yeah, this here. No more warning again that something is wrong. Now, next, in the asset library, we're going to look for a linear regression model. Remember, we're working on a regression model. So the module we're going to use now is linear regression. Yes. Bring it down like here as well. Let me use this up. Let's go and make this a little bit of space. So this linear regression model now, remember that this is still yet to be connected. So we're actually not even putting it at the bottom, but putting it right here at the left of split data. Yes, and so we're going to connect it to this untrained model. We're connecting it here. Let's see, this could look a bit fun. Yeah, this is much more neat. So this is how it looks like right now. Let me see if I can zoom out. Oops, that's so much. This is how it looks like right now. Yeah. Let me reduce that a bit. All right. So we've connected the linear regression and split data. Linear regression has the untrained models connected here. Then the results in data sets 1 are connected to data set under train model. So now we need to create a score model. So this scores the validation data set we held back when we split data. So we're going to look for score model now. Yeah, make sure it's score model that you have. So we're going to put it here below train model. It also has 2 separate outputs. So what we're going to do is, let me actually bring it here. Put it a bit here. The second bit of results data set under split data, results data set 2, we're connecting it here. And we're connecting the train model to the train model. Now, this might seem a bit confusing what we've done so far, but just notice. So, started from split data. I brought in linear regression and I edited. And so I first of all connected this to train model, that's the one on the left of split data, to the one on the right for train model data sets. So result data sets 1 to data sets. Then I brought linear regression to the left of split data here. And so I connected this untrained model to the untrained model in train model module. That can be very confusing, but I just said I connected the untrained model output of linear regression to untrained model inputs of trained model. Then split data also has something that is unconnected here by the right. So I placed score model at the bottom, from train model down to train model, and then result dataset 2 to dataset. So just looking at something quite similar, then just connecting. Each of these have what they do. Each core model is helping us to like validate basically. So we're training the model, so we're connecting this to each other. Now this is the second time we're going to be running. So make sure everything is correct from the beginning down to where we are right now. Let's see if we have to edit anything in Score model. Okay, no, we don't. So we're going to submit. We're going to go back to our existing pipeline job that we already created. And so we're going to select that existing experiment and submit. Any questions on what we've done so far? Trying to submit a second job now. So if you have any questions, not clear about what I've done, please, you can speak up, just unmute yourself, or you can raise up your hand or put it in the chat and Salim read the questions out. If there are no questions, I assume everybody understands what I'm doing. That's good. For those that also do this as well, or is anyone doing it? Let me just ask that first. I think we have about, let's see, how many participants? About 17, including me and Salim. Anyone doing this right now? Oh, okay, so someone is reacting to something. Okay, let's just the chat. Okay. I'm assuming no one is doing this. Okay, just a random question. Who can tell me the reason why I put in normalized data? I mentioned that quite a few times. Anyone would like to try the reason why I put normalized data? Why am I normalizing my data? Nobody.
Can I? Fine, try.
Yes.
I'm not sure, but I think you're normalizing data because it says something about like it not being to scale. So what you're normalizing, what the function normalize data does, I think it's normalizes data basically, like it makes data, everything is on the same scale sort of.
Yeah, absolutely correct. I just realized that I have actually kept that question at the end of my presentation. So everybody's getting that as a bonus. I always ask that. So let me look for other questions I can ask. Let's see. So what are what are the things that like determine when it comes to regression? Like what are those things that help you determine your outcome? What are the variables? Like in this case, now what are some of the variables that we've used that you've seen in the table I like in the CSV file I showed earlier? So who remember some of those features or variables that I used? Then we used to like to predict, sorry, to predict the price. Remember some of those features. Anyone? Should I call randomly? I don't want to put you on the spot, but I think I will now. Let's see. Well, just I joined from the start. Yeah, I think this person joined earlier. Ibrahim. I know there are two Ibrahims here. Ibrahim Abdurrahim. Do you remember what I did? Like, what are some of the features? Just give me any car feature that can you use to predict the price. Are you there? Okay, so some of the features I used earlier were price, Spa, peak RPM, bore, stroke, I think. Yeah, then peak RPG, something like that, yes. Then engine size, then of course price itself was there. Remember the original table that I had some of those things that were not normalized that I got off. So yes, some of those features that I used that helped me to determine what I'm doing right now. So it seems this second job has been completed. You can also go back and look at the job detail. Let's see what it looks like. All right, so everything is ticked, so everything has been completed currently. Okay, so I'm actually just getting notification that it seems I'm not seeing those that might be raising up their hand, but it's possible for you to unmute. So you can please just unmute and speak if you'd like to speak. Maybe you shouldn't raise your hand. It's going to be hard for me to also check in. So you can just unmute yourself and speak. But let's move on now since this has already been completed. So we've submitted this, we've gone there now. In the new window, which is the here we created, I'm going to go to score model. Here, I'm going to preview our data. So I right click on it so that we can right clicking on it so we can preview our data. Score data set, yes. All right, so you can see that everything looks normal now. Some of them don't have only numbers, but you have like their make, like different car manufacturers here. Then their fuel type. Then some of them use diesel, some of them use gas or petrol as we know it. Then aspiration, don't know what that is. Number of doors, body style, drive wheels. And these are some of the features basically. And all look okay. So there's nothing that has null values. So you can see the effect of the two jobs that we have done. All right. Go to our price. This is the price range of this random cars and the manufacturers. So yeah. Yes, we're done with this now. So let's go back to here. I want to evaluate our model. We're going to come back to our asset library and look for evaluate model. Yes, first option here. So we're putting it under score model, connecting the output of score datasets to score datasets. This one here is score datasets, and this is score datasets to compare data frame directory. Yes. So is it correct? And then we're also going to submit again. This is like stage, I say stage 3. This time around, we're now trying to evaluate what we've done now. So press submit isn't existing. And we're also going to wait again. So like I said, if you have any questions or anything you'd like to say, you can just unmute yourself and speak instead of raising up your hands, since you might have difficulty doing so. So let's see. Let's also go to job detail. Let's see how far it is, how long it is with evaluate model. So you can actually see like the timeline, you can see it evaluating in real time. So when this turns green, check mark, so you know we're done. So going to actually explore some things in the results of this evaluation, some things that you might have heard, look familiar. I'm going to check them out. So let's give it a few minutes. For those that may have just joined, we are currently running the third job, which is evaluating the model. And so waiting for that to complete. Like we have waited for all the others. Specialized and muted. So if I'm asking one more time, if anyone has any questions on what we've done or you're lost, please do help to speak up and let me know how to help you. I think he's going to finish pretty soon. So you can actually say that this is one of the perks of using a higher, what was it we used earlier? A higher credit base. How will I put this? So if you have a much larger subscription, you can actually decide not to use a virtual machine like we used standard DS11 or something like that. You can go for something higher. Just look at the cost and the RAM, like I mentioned. So it's faster for you. But here we're trying to make use of best available resources that you can use right now. So that's why we're using something like that. But wait. Okay, I have another question. So remember here under the asset library, we have data and components. So what are these components? What are they used for? So just unmute and speak. Anyone who would like to try? What are components? Hmm. Okay, so for everyone again, components are basically some of those modules that you use in order to transform the data set. So we got our data from here, data as name implies, but then these components are these different things that help us to achieve our end goal of testing and getting our regression model ready to use. So components include things like training the model, splitting data, normalizing, cleaning, evaluating, and scoring. So that's what components are. So yes, we're very fortunate that it has completed now. So let's go to job detail again. First, I already opened it. So it's still a third. Yeah, this should show as completed. All right, good. So I want us to look at something under evaluation results. Now we've seen these values, mean absolute error, root mean squared error, relative squared error, relative absolute error, coefficient of determination. These things actually kind of resonate with me because I know I've seen something like, root mean square, coefficient of, there's this words that we use in economics back in secondary school. So we are just somewhat the same, just a little bit of difference. So mean absolute error is you are getting the very best average value for difference between the predicted values and the real values. So root mean square is not like the square root of squares of both the predicted and the regular. Coefficient is something similar to square. Division is like just a random value that gives you like the highest. Let me give you the perfect explanation from Microsoft. Okay, so Microsoft Lenses coefficient of determination is most known as R squared. So it summarizes how much of the variance between predicted values and true values is explained by the model. So it's like variance and then the one that you have square root of variance, something like that. So it's like the same terminologies that I used. Relative squared error is the relative metric between 0 and 1 based on differences between the predicted and true values. So all of this has to do with the predicted and the true values. So we're done with evaluating our model. Now let's go to deploying a predictive service. So we're going to go to inference pipelines. So let's go back. I think we can cancel all of these. We don't need them right now. So here, let me go back, close this up. So let's see. I think I'm gonna have to use submitted jobs again. I want to create an inference pipeline. Yes. So we're creating an inference pipeline and we're creating one that is real time or batch inference. Yes, we're creating a real-time inference pipeline this time around. Other examples that I've seen, they create batch inference pipelines. So real-time inference pipelines now helps us to remove some of the training components and now add some new web service input and output. So we're going to remove some of the things that are here and put in some new things so we can handle my requests. So we're creating inference, creating a real-time inference pipeline. Yes. Have we in the created real-time inference pipeline? All right, we are. Let me reduce this. This has added, like I said, it has added some new things. It added web service inputs, and at the very end here, it added a web service output. Now, what are we going to remove? First of all, automobile price data. So we're going to remove this. We're going to delete, and we're going to put in. All right, yes. Yes, so I'm going to put in this time around. Let me see. It's enter data manually. This is where another CSV file comes in. So that's going to be under, it should be under components. Data. Yes. So replacing it here. Data manually. And we're going to connect it back with select columns in the data set. Now we have to put in our data, our CSV file. So let me quickly get that. We have to pause my presentation. What's in my CSV file data? I'm going to share my screen. Yes. So I'm going to come here and edit code. I'll give you it CSV file. Steven. Still come back to check it has been done. Yes, now it has popped up. Correct. So yes, correct. Okay, so we've handled this now. Coming back here now, in selecting columns in data set, I'm going to come and remove price. So let's scroll down. Remove price. Everyone is following. If you're not doing it, remember there was a link that Salim sent earlier that contains the link to the module, which is what I'm also using that's guiding me here. So you can all be checking as I'm doing things here. And if I also make a mistake, you can also notify me so that I can correct that. So yes, we have removed the price field with select columns in datasets. All right, now next it has evaluate model, which is what we did last. It's not useful right now when we want to predict, so we're going to delete. Only get it to give us our main coefficients, and things like that. So we deleted that. Now, for the score model, the output has both input features and predictive model. So we want to get that. So first of all, we're going to have to delete the connection between the score field and web service output. So we're deleting this for now. So we can edit. Yes, okay, we deleted that. So we're going to add another one. Remember, we said we're going to also work with a bit of Python, execute Python script. Execute Python script. It's going to be here. What this Python script is going to do now is that the scored labeled column. There was a scored, that's something I think I forgot. So I was going to show you when I have this my score model, you know, I went to check preview and I checked the results. There's a new column that has been added called scored labels. So the new name should be predicted price. So we cannot do that manually anymore. So we need the Python script. So this is all we're going to do now. So we're going to get the Python script. Let me just go straight to the presentation, which contains my script. And I'll copy that. All right, I'm back. So edit my code, everything here. Delete this, and then replace them. So this, like I said, replaces scored labels column with predicted price. It renames that to predicted price. So it already predicted, giving us a new set of predicted prices for newer things, newer cars that have same features or similar features. I'll come here again to make sure that it reflects. All right. So that is done. We've added this. There are two data sets and then a script bundle. So we're going to connect scored data sets to the first one. And the output of this, we're connecting it to the web service. So we might just decide to bring it down a little bit. I'll connect it here. So then schematic forms. Yeah. So I have a sample here, so I have to be sure that it looks exactly the same. Yeah. So like what we've done now, we removed automobile price. We've added our own external data CSV file. Then of course, web service inputs and web service output has been added. Then we've added a Python script, and then yes. So everything looks good. Now we're going to submit for our fourth job. And this time around, we're going to create a new one. Since it's an inference pipeline, a real-time inference pipeline. So we're going to create a new one. The name is MS Learn Auto Inference. Yes. Submit. I'm already notified here that this experiment is going to take some time to run. So let's see what we can do in the meantime. We actually just have about, let's see, 2 more steps to go, and then we're done. We're able to test our service. So after this now, we're going to deploy this model that we've done, deploy the service, and then test the service. And well, right now I can ask questions, and I'll also get some questions to ask. So if you have any questions, again, please, you can unmute and speak. My new question is, who remembers the reason why we are executing the Python script? What was that for? And unmute and speak.
I guess we're adding the Python script so that we can add more information to the already model that I've created.
I like your perspective, but not exactly. Who else has another opinion or another answer? Okay, so what I did was, remember, I told you that when I did the score model, when I added that when I added that component to my pipeline, there was a new label that was created. So it was called scored label. That was the name of the column. I mean, I should say column. A new column was created. It's together with price, horsepower, and all those normalized data already. There was a new one created called scored label. So I cannot edit now. I can't go back there to edit the new from scored label to predicted price, because that scored label is actually the new set of prices that have been predicted. So this code is used to change that. It's used to help me rename that. So yes, that is what I did. This is going to be if this is working here. I have to just start explaining my next steps. So, like I said, next step now is to deploy our model, to deploy our service. So what we're going to use to deploy now is Azure Container Instance. Although if you're working, we're just doing it as a test, it's just an example. But if you're working in a bigger company, a bigger organization that you've used more credits for, and it's production level, so there's something called Azure Kubernetes Service, AKS. So that one provides better, it's faster, of course. If you have more credits, it's definitely going to be faster. Then it gives you more security, and it's much more scalable, meaning you can easily, get all these things as fast as you possibly can. And you can easily transform data sets. So it doesn't take as much time as this. But for this instance, since it's just an example, so we're only going to work it on Azure Container Instance. So just in case you ask the question like that, it's Azure Kubernetes Service that is the ideal thing for deploying the model. But for certain cases, you can use the Azure Container Instance. So when we're done, when we click on job detail, it should be able to allow us to deploy a service. This is blurred right now because it's not completed. Yeah, it's still running. Let's see where it is now. Okay, it's applying transformation. And to execute a Python script, and then we're done. Okay, so you should be able to deploy a service. Deploy means you're just publishing it out so that clients can use. Like I said, this is just an example, so we're not really publishing it out, which is why we're using a smaller version, ACI. So you're going to deploy the service that we've just done. You're going to rename it, give it a new description and compute type. Then when it's deployed, you will see the status at the top. We're now going to test it. That's where we're going to use a bit of JSON data. So that is where you will see endpoints, which is at the bottom here, come into action. So we're going to edit these endpoints with our own, some data is going to put there, just some state data. We're going to edit that and add our own JSON data. It contains, what I'm seeing here, it contains symboling. So all of those features earlier on. So there are some numbers that have already been placed. Perhaps this car, the make is Alfa Romeo. Never heard of that. So the fuel type uses gas. Then it has 2 doors, a convertible. So it gives us all of this. So based on the information that we have trained and we have like done the running for, we can be able to predict the price of this car with the new details. It gives us everything we possibly need. The make, like I said, number of cylinders, the engine type and size, compression ratio, horsepower. So it has seen how those cars and their features work. The former cars, now looking at this, it can just give us the easy prediction. And so when we put in our data into that module, it gives us a test result and it gives us the predicted price. So we hope that it works. Fingers crossed, should work. I will link to the next. So we're waiting for this to complete. It will soon be done as it's scoring the model. So questions. Let me ask questions as well. From Sally's presentation, who remembers the 4 steps that we mentioned? Or you can give us at least just one and explain what's the first thing to do when you want to evaluate and train a regression model. Does anyone remember that?
I guess you will type evaluation, then you will see evaluation on the list of, then you now press it, then it's now bring out a new window.
Okay, that's one of the first step. That's I think the third or fourth step. The first step, what's the first thing you have to do when you get raw data that you have some things that are null, some things are empty, you have data that is not normalized? I'm already giving away the answer. What do you do? What's the first step? I remember the first job that was submitted. What are some things that we added? Yeah, someone is called my name here. Meeting is about to end. Let me see if I can remedy that. But the person that is called Sholakuni, if you can go ahead. Hey, Ibrahim, sorry, please. Ibrahim, go ahead instead. You can unmute and speak.
I think it's to check for a relationship between the variables. So I'm guessing normalization.
Yes, you're correct. So you first of all prepare your data. So preparing has cleaning, normalization, executing, and things like that. Okay, please give me a few moments. I'm realizing that the meeting is about to end, so I want to edit that. Rosaline, do you have any solutions to that? I can just actually edit from my end anyway.
Let me check what I can see.
Extended it. I think I have extended it to 1830. Yeah.
That's fine.
Yeah, so update should have cleared. Okay, so it has actually ended. It has finished that. So let me go back and share. It has finished that job. Yeah, it's completed. Completed. Good. So I'll come to come and deploy now. Yeah, this should. Let me open it again. Job detail. We're here for deployment. Yes, good. So deploy. So our new name, we're deploying a new real-time endpoint since we haven't created and you can't replace. So the name is predict auto price. Great, it's already there. Our description is auto price regression. And remember, like I said, we're not using Azure Kubernetes service. We're going to use container instance for this situation. And so we deploy. I don't know if anyone noticed, but just now as I was trying to deploy, you notice that it took some time before it could, the deploy button, changed to green or something, or blue. That was the color there. You know, that's the AI in action. Because this website now is trained to only give you access to some certain things only when you have satisfied what they need. So they see that you've put in the name, they see you've put in your description, and then you have selected your compute type. That is when they can open that. And that situation where you can see this is, I'll show you very soon. Now, when I'm trying to delete, I have to write in, if I want to delete everything I've done here, now like delete this job, I have to write in the name of the job first before I can delete, before the delete button is no longer grayed out, but it's now able for me to click and delete. That is AI. That is machine. No, it's AI. That's AI in action. I've forgotten the specific name of service that does that, but it's kind of expects you to do some certain things first. So it sees those things, you've satisfied all those requirements, and then it gives you what you need. So these are, you can see applications, real-time applications of it. So deployment is in progress. We're going to wait. Do I have any other questions? No. Let's see. So do you have any questions you'd like to add, like ask those that are here? I'm actually just scanning through to call we've covered before the knowledge check.
Let me look up for something. Okay. Oh. So yeah, I'm going through convenience.
I'm doing the same thing.
All right, so I talked about auto ML. Can anyone remember like anything I said about that? Just anything whatsoever. I want to build on the points. So just anything would do actually. Just tell what comes to mind when I say the word auto ML.
Just
Anyone
remember
at
that if
all?
you're raising up your hand, sorry, Salim, if you're raising up your hand previously, you may want to remove that unless you want to answer the question that's been asked.
They already raise their hands down. I mean, just anything whatsoever. Like the first that comes to mind is like I just need you to say something, and I'll build on the point. And I have
guess
like the
auto
correct
ML.
spelling on the chat. I got.
I guess auto ML is when Microsoft helps you to create your machine learning model.
Yeah. That's about it. Thank you very much, Dokas. So basically, it stands for automated ML, and like it's what we're doing here today. It takes it a tiny little bit further in the sense that a lot of things are done for you. So just it's abstract this, the same way this Microsoft Azure Machine Learning Studio abstracts the writing of code. What AutoML does is it's almost like it abstracts this. Now, obviously, it has its demerits and all that, because with this one, you have a lot of control over your model, and you can make it, you can fine tune it to what you want. But then with AutoML, like all that is abstracted away from you, and like you just give it the data sets and it gives you back a model, which you can then deploy and publish. Right. So that's that. Thank you very much for answering the request. So like the point about AutoML goes back to like, I'm sorry about that. It goes back to like it buttresses my point about there's a slide that we had like a level of control where I talked about it decreasing from left to right. So I kind of like buttresses my point. So from left to, I think the at the extreme left you have the AutoML, and then you have the Microsoft Azure Machine Learning Studio, which we've used today, and then you have a Jupyter Notebook. So as you go from left to right, it becomes, I won't say other, but you have to do more things. Okay, so that's that.
Yes, it's correct. It's, you can say harder actually because it's more advanced. So let me pop up that slide. Let's see if I can stop sharing and then share the slides. Yes, so this slide in particular is what he was talking about. So you have from left to right. For beginners in low code, you use AutoML, which gives you automatically, then designer what we're using, then notebooks, which is kind of in the middle. So it's a bit for beginners, a bit for advanced people who have experimentation and deployment. So it goes from left to right. All right. So let's check
AutoML is
up
something you can
on,
actually like explore.
let's check on our endpoint. Deployment is taking quite a while. It's about 6 minutes now. I really hope it doesn't extend to 10 minutes. Everyone that has waited so far, thank you very, very much. I really appreciate you. This is how it's this is how it's done, really. You wait for a period of time so that it can work. Members, Sally mentioned another word you can use for pipeline, and that really resonates with me because it makes a lot of sense. Who remembers what it was? We called pipeline something else. Does anyone remember? Let me give you a hint. It's something that is used in when it comes to data hierarchy, I should say. Yeah, it should be data hierarchy. It's a very popular thing. Like it gives you this visual look of how things are meant, like steps. You have this, should I say, drawing a diagram, gives you like steps in different anything you want to literally, but mostly when it comes to like data hierarchy. Does anyone know that? Wow. Are you thought people remember that? So you call it flowchart. You can call a pipeline, can also say it's like a flowchart. And you can look at it does it not look like a flowchart? I mean, all the connections we've done, and it's advances. So then we have to push to the side because they connect with this, they connect with that. Flowcharts is a systematic process. So each of them, they relate with one another and intertwine you. They see two things, even intertwining with one module or something. So yeah, you can actually call it a flowchart. Something I didn't forget now. Pipeline is basically a flowchart. Yeah. Deployment is still
Yep.
taking quite a while.
So like, just to purchase a point about the flowcharts, like it goes all the way from the data to the trained model, like to the deployed model rather, like it's a flow. Like you can just see it's moving. I actually don't know. Personally, I think flowcharts makes more sense than pipeline. Pipeline, it's not. I mean, what's pipeline like? You get like flowcharts makes much more sense basically. And again, I don't know why I keep advocating for AutoML, but again with AutoML, all that is done by Microsoft Azure. Maybe because I don't like stress honestly. So like with AutoML, all that is done by Microsoft Azure. All right,
Okay.
so
So
guys, while that's going on,
you can go ahead.
let me just pass this. So basically, yeah, I feel like this would be a good platform or like a good opportunity for me to tell us about the Microsoft's. Oh, my network is bad. Okay, as I was
We're
saying, it would be a
hearing.
good opportunity for me to tell us about the Microsoft's certification for students. So basically, imagine how nice this would look on your resume or perhaps your LinkedIn profile if you had a little badge that says Microsoft certified in whatever tech stack you're doing that has to do with the Microsoft products. So there are AI exams you can take that has to do with Microsoft. That there are AI Microsoft certifications. You have business analytics, cloud computing. That's just the regular Microsoft Azure exams, and you can imagine that would look very nice on resume. And Microsoft's they are so generous such that you can take these exams for free as students. Regularly these exams cost. I think the fundamental exams they cost $55 in Nigeria. So $55 using the black market rates would be around let's say like a little over 30,000 naira basically. But as a student, you won't get to write, you won't get to pay that much actually. You won't get to pay at all. So I'll send the link to that. Basically, all you have to do is just verify that you're a student. Upon verification, you'd have to take a mock examination. So the way it works is the pass mark for each, for I think every Microsoft certification exam is 70%. However, for the mock exam, you have to get 80%. Then upon getting 80%, then you get a free certification. So it's almost like a scholarship in the sense that what you're doing really is you're trying to play it safe. Like there's no way you get 80% in the mock exam and fail to get 70% in the regular exam. All right. So I'll send a link to that. It's pretty easy for you to follow through. And if you have any issues, be sure to reach out to Sholakumi or myself. I'll send the link right away. Sholakumi, you're going to say something.
Let's mention that I'm looking at those that are here, and they look like those that are in year one, just about like except for a few people. So just in case you guys haven't completed your like me, I haven't done my ID card, so I couldn't use that to verify for other students. And I've also not gotten what's that? The ID card and one other thing. There are different options actually for student verification. So what I used was my
Your student
acceptance
email
letter
address.
that I got from JAM. No, I don't have a student email address yet. I don't still because everything got held up by the strike.
That makes sense.
So I used my JAM letter that was sent to me that I got admission into Unilag. So that just worked. Like within, I think, a day or two, they did that automatically.
Yeah.
And in fact, for those
Really
in
nice.
secondary school, something like a letterhead from the school that's just telling you that, yeah, you're a student of this school and certain date. And that worked for my younger brother. And I think within 2 hours, he was immediately verified. So it's pretty easy for those that don't have student IDs or email addresses. So yeah, let's check on our, wow, this is taking,
So
I
not
would
done.
not have expected. I would have expected this to have taken this much time. I really wanted to show you all how it should look like, but we're already going out of time. So let me see. I would just like to open the Microsoft Docs. Yes, I think I'll just open. So Microsoft Learn already did it something similar. So let me just show you what they got in the exercise. What the link Salim sent. What's going on? Okay. So it's the 30 last minutes in that exercise. Can I change this to like no? Okay, it's going to take quite a while before I can change to like, so please bear with me. Okay, yes, should be here. All right, good. So what we're doing right now is deploying. Yes, they themselves, they know that it's going to take a while. So they said I should wait a few minutes for the web service to be deployed, and then I'll see the status. Now, remember, I came here to details, then I come to tests. It should be showing me this instead. This is what I should be seeing, something like this. So I should be seeing a way for me to input data. That is where this my JSON data comes in. So I'm going to test my model using this data. Like I said, the make of the car is Alfa Romeo and it uses gas, number of doors, 2, it's a convertible, and it has all the other features though. So I copied this. I'm supposed to copy this and then paste in, oops, excuse me. I should be pasting, yes, I should be pasting in this box. This box is meant to be empty. So when I paste that, I'll click on test. And if everything goes according to plan, I should get the predicted price. So according to all those features there, the features might have changed. This may just be some older features, but according to the features in this picture here, the price for this car is, let's assume it's in dollars, 14K dollars, roughly about 15K. So we can see how this works. This is what we're supposed to do at the end. But if everyone wants to try that in their own So this is at the end. All done so far in modeling, cleaning, making sure that that test data is going to go so you can use it to predict future prices. So that's really it. I have one more question for everyone. Let me go to my presentation slides. Question based on what we've done. Done. Okay, so we've answered question one already. The question was, you're creating a training pipeline for a regression model using a data set that has multiple numeric columns in which the values are on different scales. Scales is the keyword. You want to transform the numeric columns so that the values are all on a similar scale based relative to the minimum and maximum values in each column. Which model should you add? So I kind of gave this away already. Normalizing when it comes to putting things on a similar scale, you normalize. Let's try another question. So question 2, why do we split our data into training and validation sets? Why do we split our data into training and validation sets? The first option is it because data, when you split data into two sets, you need to create two models, one model using the training set and a different model using the validation set? Is that the answer? Or is it that when you split data into two sets, you're able to compare the labels that the model predicts with the actual known labels in the original data set? Or the third option, that we only need to split our data in Azure ML Designer, not in other machine learning scenarios? Who can give me the answer to this? Who can assume? First of all, what options would you remove from here? Which options don't look feasible? You can just unmute. Anyone? I really don't want to call random people. Remember we did splitting earlier on, so, or if you don't want to answer which one you remove, which one would you pick? Just pick a random option or one that you feel is close to the answer and we'd explain what the answer is. Let's be shy. We're all learning.
I think it's A. I'm not sure. I think it's A.
Who's that?
Salim, yeah.
Okay. Any other person would like to give a different answer? Or a different viewpoint?
I think it's B.
Okay. Thank you. Any other person?
I guess it's B.
Okay. So since everybody is giving a different option from Salim. Salim, would you like to tell us the reason why you think it's option A?
Wow. No, I wouldn't.
So you're already guessing you're wrong. I don't want the learning process. Actually, we think it's option A, but really, the reason why it's option B is because we are testing our model that we've created with training data on validation data. So the training data is the original data set, and validation data is the model that has been predicted. The data set is the model that has been predicted. So splitting data helps you to compare. Well, it's quite ironic that splitting will help compare or something, but that's what it is. So you are comparing the new model prediction, new predicted data to the original data sets. So that's why is the answer. And no, although I haven't personally worked with other machine learning scenarios, but I don't really think the answer should be because splitting data only works in Azure Machine Learning Designer. I mean, you're already seeing benefits of splitting, helping you to compare. So I don't see why other machine learning scenarios should not have it. But yes, that is it basically.
I'm sorry,
So
I didn't get the last part.
okay, I was trying to explain why last option not make sense.
Like,
I
saying it's
haven't
about
worked
machine
with
learning
other.
engineers.
No, I was like, I haven't seen other scenarios of machine learning. I've only worked with Azure, but I don't think that splitting
Oh,
would only work in Azure. It should be able to work in other scenarios
it
since you've seen the benefits of
works in every
splitting.
other scenario, right?
All right,
Works in every
good.
scenario.
The learned person among us has spoken. All right, so let's just round up the presentation. Yes, it's correct answer. So what are we going to do now? Let's clean up. So in order for us to avoid wasting our credits, remember it was just $0.20. That's about 20, what is it, cents? Yeah, I think it should be cents,
Yes,
20 cents per hour. We spent about 2 hours or so, so we spent about 40 cents or something. So let us go ahead and clean up. Let me go back to here. I'm going to clean up. So we're cleaning up 4 things, or it could be 3 here. So first of all, let's go to, okay, our endpoints didn't work out. Or it did? Okay, it did, yes. So we are going to delete this off. Let's come up. So we're deleting this. You have to request to delete. Yes. Let's delete this. Yeah, we want to delete it. All right. So notification is going to be up there. Okay, this endpoint actually failed. Something, I might have done something wrong somewhere, so perhaps that's what's going on, which is why it failed. But nonetheless, I'm deleting this. There are no bash endpoints. So I'm deleting my endpoints. Next, I will to delete my compute. Under compute clusters, deleting this. Yes, we're deleting. Yeah, I think this was come. So we're trying to delete something. Then next, we're deleting the resource group. What is it deleting? Let's delete all of this. I'm deleting compute, so perhaps this one will also delete themselves. All right. Let's see if it also delete too. Oh, yes, you can. Now see what I'm saying now. It's unless I type yes, it comes up. If I type no, no options, nothing. So only if I type yes. So presence of AI here. Deleting. All right, yes. All right, let's go back. Delete the next ones, which I'm also guessing must have been deleted by themselves. Okay, under jobs. It's deleting. I deleted the inference, so I think I should be able to kill. Yes, it's all 3 of them. If I type yes, comes up. The other thing is that this is also security wise, it's good because just in case this is a mistake, it could just be a mistake. And imagine if you just mistype or something falls on your keyboard, anything could happen. So this is pretty much wise and part of Microsoft for them to be able to give you that pop-up again as warning you that, oh, you are deleting this. Are you sure you want to delete it? Type here, you can be sure. And as it said, not a robot. So, okay, this is done. Inference is also done. All right, now let's go to our workbooks. Now, very beginning. Can this is from here. you'd like. Let me see from here. Okay, no, you can't. So you have to go back to where we created this workspace event demo. I'll click on delete. Let me delete. Wait for that. How I know it's fully deleted is I'll go back to the sites that I opened now and I'll refresh. And it gives me the pop-up. If it's still working, that's another okay, this has not deleted. And I'll go back through all the same processes. But yeah. So the deletion might also take a while. So that would be over some time very soon. It will soon be done. So, oh, okay, good. It's deleted already. So, yeah, good. Refresh here too. Reload. Yeah, sure. To notice very soon. If something is wrong with the workspace, it's no longer here. What's going on? Yeah, workspace not found. Same thing, something similar will occur here if we refresh and refresh here. Okay, good. So workspace is not found means it has been deleted. I'm even expected to sign in again just to verify this. So yes, so that's it. So let's just go for a proper summary now for what we've done. I'll go back to my presentation. Okay, so you've cleaned up, you've deleted all of those, the endpoints, compute resource group, and the workspace. Now, what have we learned? We've seen how to use the Azure ML Designer platform to create, train, and publish a regression model. So Salim started out by explaining what machine learning was, the approaches, and then what regression is, then the steps in regression, and I took over by showing you how that works. I'm very sorry that it couldn't work. I don't know what I might have done wrong, but at least up to the point in which we've ended, we've seen how each of those things are, and they've also shown you from Microsoft Learn, the docs, how the results should be. Now, what I would like you to do as a follow-up project is to learn how to use the other approaches to machine learning. Remember that they have two, supervised and unsupervised, and under regression, you have under supervised, you have regression and classification, and under unsupervised, you have clustering. So each of these, we treated regression today, each of these classification and clustering, and also a much more detailed explanation to machine learning, how AutoML works, and how you can also use AutoML and exercise. So all of this is contained in Microsoft Learn modules. So what we've done today is a branch of what you can use to prepare for one of the certification exams that Salim mentioned, Azure AI fundamentals, Azure AI fundamentals. I've taken the exam, Salim also took the exam, and kind of knowledge. It's very, very, very interesting material that's there. This might only be the complex parts. The other ones have things like custom vision, computer vision, and I think you all to find that very interesting. So thank you very much for joining. Thank you. If you like to connect with me and Salim and I, here's our social media. It's GitHub, Twitter, LinkedIn, and mine as well. Thank you once again, everyone, for joining this presentation. So it's time for questions. Salim, if you have anything you'd like to add as well, you can come up and speak.
Anything I'd like to add? Nothing whatsoever. It's been really nice. Well done, Shalakumi. your what's it called now? Your live session was really nice and explanatory. You did well to explain every part of it. So well done. And huge thanks to everyone who stayed until up to the end. I mean, it took a little longer than we expected. We're grateful that you stayed up to the end, and then we hope that you've learned a thing or two. Maybe not a thing or two, a lot of things from this session. So thank you very much, everyone. And have a
Thank
good
you.
weekend as well.
Yes, have a great weekend. Let me post the link again to this module. I'll stop sharing now. So in the chat, so if you'd like to explore that, yes. Wow, why is it so huge? Anyway, so yes, that's the link to, it has each of the models: introduction to machine learning, regression, classification, and clustering. So check that out, knock yourself out, and like Salim said, thank you very much, everyone, once again, and have a lovely weekend. Thank you. Thank you.
All right, guys. Bye. Bye.
Thank you, Ibrahim. Let me stop everything.